Donuts may seem simple, soft rings of fried dough coated in glaze or sugar. But producing Dunkin-style donuts at massive scale is a carefully engineered process that balances dough chemistry, fermentation control, frying physics, and high-speed finishing. Every donut must rise the same way, fry evenly, absorb just the right amount of oil, and emerge with a light interior and smooth, glossy exterior. What starts as basic ingredients like flour, water, yeast, and sugar is transformed through precise timing, temperature control, and automation into millions of identical donuts every day. Today on The How Factory, we're stepping inside commercial donut kitchens to see exactly how Dunkin-style donuts are made. From dough to glazed perfection, the modern donut has roots that stretch back centuries, but the ring-shaped yeast donut became popular in the United States in the early 20th century. As donut shops expanded and chains emerged, consistency became the defining challenge. Customers expected the same softness, sweetness, and texture at every location. That expectation drove the evolution of donut making from small batch frying to standardized, highly repeatable production systems. Dunkin-style donuts are designed to be light, airy, and uniform, a product of controlled fermentation and efficient frying rather than heavy cake batters. The process begins with dough mixing. Large commercial mixers combine wheat flour, water, sugar, yeast, salt, milk solids, shortening or vegetable oil, and dough conditioners. Flour provides structure through gluten formation. Sugar feeds the yeast and contributes sweetness and browning. Yeast is the leavening agent that creates the donut's airy interior. Fats improve softness and mouthfeel, while conditioners help ensure consistency across batches. Mixing is carefully timed. Too little mixing results in weak gluten development, causing donuts to collapse or fry unevenly. Too much mixing makes the dough tight and elastic, preventing proper expansion. Industrial mixers monitor speed, torque, and time to reach the ideal dough development point. The finished dough is smooth, slightly tacky, and elastic enough to stretch without tearing. Once mixed, the dough enters the fermentation phase. Fermentation allows yeast to consume sugars and produce carbon dioxide gas, which creates air pockets inside the dough. This step is critical to texture. Dunkin-style donuts rely on yeast fermentation rather than chemical leavening, giving them a lighter, bread-like crumb. The dough is transferred to proofing rooms or resting conveyors where temperature and humidity are tightly controlled. Warm temperatures encourage yeast activity, while humidity prevents the dough surface from drying out. During this rest period, the dough relaxes, making it easier to shape later. Fermentation time must be precise. Under-fermented dough produces dense donuts. Over-fermented dough becomes fragile and collapses during frying. After resting, the dough moves to sheeting and cutting. Automated sheeters roll the dough into a uniform sheet of precise thickness. Thickness consistency is essential because it determines fry time, internal texture, and final weight. Optical sensors and rollers maintain even thickness across the entire dough sheet. Donut cutters punch out the classic ring shapes. Each cutter creates both the outer ring and the inner hole simultaneously. The dough scraps and donut holes are collected and either processed separately or recycled carefully back into the dough stream in controlled amounts. Excessive rework can weaken dough structure, so limits are strictly enforced. The cut donuts are placed onto proofing trays or conveyor belts and move into final proofing. This is where donuts gain most of their volume. Final proofing chambers maintain precise temperature and humidity levels, allowing yeast to expand the dough without drying the surface. During this stage, donuts visibly puff up and become light and airy. Final proofing is one of the most sensitive stages in donut production. If proofed too little, donuts will burst or crack during frying. If proofed too much, they may collapse when transferred or absorb excess oil. Automated systems monitor proof height and time to ensure donuts enter the fryer at the perfect moment. Frying is where the donut truly becomes a donut. Dunkin-style donuts are fried in large, continuous fryers filled with vegetable oil, typically maintained around 350 degrees Fahrenheit to 375 degrees Fahrenheit, 175 degrees Celsius to 190 degrees Celsius. Oil temperature is critical. Too hot, and donuts brown too quickly on the outside while remaining raw inside. Too cool, and donuts absorb excess oil, becoming greasy and heavy. As donuts enter the fryer, they float due to steam formation and internal gas expansion. The bottom side fries first, developing a golden crust. After a set time, automated flipping mechanisms turn the donuts so the other side fries evenly. The characteristic light-colored ring around the center of the donut, often called the proof line, forms where the donut was partially submerged during frying. Frying time is carefully calibrated, usually under 2 minutes total. During this short window, starches gelatinize, proteins set, sugars caramelize, and moisture evaporates. The interior becomes soft and fluffy, while the exterior develops a thin, slightly crisp shell. Oil absorption is minimized through proper dough formulation and frying conditions. Once fried, donuts exit the oil and move along draining conveyors. Excess oil drips away, and airflow helps stabilize the surface. At this stage, donuts are fully cooked but unglazed. They appear matte and slightly rough, ready to receive toppings. Glazing is one of the defining features of Dunkin-style donuts. The classic glaze is a simple mixture of powdered sugar, water, or milk, and sometimes vanilla or corn syrup. The glaze must be fluid enough to coat smoothly but thick enough to set into a shiny, slightly crackled finish. Glazing systems vary, but many operations use waterfall or curtain glazing. Donuts pass under a continuous curtain of warm glaze that coats the top evenly. Excess glaze drips off and is recirculated through filtration systems to remove crumbs and maintain consistency. Temperature control is essential. If the glaze is too cool, it sets too quickly and coats unevenly. If too warm, it runs off completely. As the glaze contacts the warm donut surface, it partially melts and then sets as the donut cools. This creates the smooth, glossy finish associated with freshly glazed donuts. Some donuts may receive additional toppings at this stage, such as sprinkles or sugar, applied while the glaze is still tacky. After glazing, donuts move through cooling tunnels or ambient conveyors. Cooling allows the glaze to set fully and stabilizes the donut structure. Airflow and spacing prevent donuts from sticking together. Cooling time is short, as yeast donuts are best when fresh and soft. Quality control runs continuously throughout production. Operators monitor dough consistency, proof height, fry color, oil quality, glaze thickness, and final appearance. Color sensors ensure donuts meet visual standards. Weight checks verify portion control. Texture is assessed to ensure softness and resilience. Oil management is also critical. Frying oil degrades over time due to heat and moisture. Filtration systems remove crumbs and particles, while regular oil turnover maintains flavor and prevents off notes. Oil quality directly affects donut taste and shelf life. Once cooled and finished, donuts move to packaging or display preparation. In large distribution systems, donuts are placed into trays or boxes designed to protect shape and glaze integrity. Packaging must allow ventilation to prevent condensation while maintaining freshness. For in-store production, donuts move directly to display cases for immediate sale. Behind the scenes, sanitation is a constant priority. Dough mixers, proofers, fryers, and glazing systems are cleaned regularly to prevent buildup and contamination. Yeast dough environments require strict hygiene due to moisture and warmth. Food safety protocols govern every step, from ingredient handling to finished product. Consistency across locations is achieved through standardization. Ingredient ratios, proof times, fry temperatures, and glaze formulations are tightly controlled. Equipment is calibrated regularly, and staff are trained to recognize subtle changes in dough behavior. Even humidity and altitude can affect donut production, requiring adjustments to maintain uniform results. Sustainability is becoming increasingly important in large-scale donut production. Energy-efficient fryers reduce fuel consumption. Oil recycling programs convert used frying oil into biodiesel. Ingredient sourcing and waste reduction initiatives help minimize environmental impact while maintaining product quality. What makes Dunkin-style donut production remarkable is how quickly and precisely it operates. From mixing to glazing, the entire process can take just a few hours. Yet within that time, dough chemistry, fermentation biology, and thermal physics must align perfectly. The result is a donut that looks simple but depends on dozens of controlled variables. From flour silos and industrial mixers to proofing chambers, continuous fryers, glazing curtains, cooling conveyors, and packaging lines, donut production is a streamlined system built for speed, consistency, and freshness. And that is how Dunkin-style donuts are made. Mixed, proofed, fried, glazed, and cooled, transforming soft dough into golden rings of glazed perfection, ready to be enjoyed fresh. Thanks for watching The How Factory.